Hypothesis testing the population proportion using a calculator. That's what this video is about. Here we go. Okay, so up to now we've talked about how to perform hypothesis tests of population mean. Well, also sometimes you want to perform a hypothesis test of a population proportion. Well, a proportion just means a percentage of something. And so the hypothesis test that we use for this is something that's referred to as a one prop z-test. The one means that you're conducting one sample or one survey. That'll make more sense in a later video. And the prop is short for proportion. So how do you get to the one prop z-test? Well, you hit your stat button. You go to the test menu, and it's number 5, one prop z-test. Okay, and then as you click on that, you see that there are a few values that we need to input in order to get eventually the p-value. What are these things? So I just took a screenshot here. So your p naught is your hypothesized proportion. It's very similar to your mu naught in the sense of it comes from your hypothesis. Okay. Your x is the number of successes. So when it comes to proportions, you're going to have a number of successes, and then you're going to have your sample size. Okay. And then, as always, we have to determine whether or not we have what type of test we have. Is it two-tail, left-tail, or a right-tailed test? Okay. As always, there are certain conditions we need to have in order to perform a one prop z-test. The conditions are we need n times your p hat. Your p hat is your sample proportion. We need n times p hat to be greater than or equal to 10. And we need n times, it's called q hat, but I'll write it like this, 1 minus p hat. We need that to also be greater than or equal to 10. If you've had any previous exposure to maybe binomial probabilities or anything like that, you know that your p hat is your success rate, where 1 minus p hat is your failure rate. These conditions will be satisfied for you in this video, but I do want you guys to know that we need these conditions to be met in order for us to perform a one prop z-test. And basically all this is saying, hopefully it's not too confusing, p hat is equal to your number of successes divided by your sample size. So the proportion of successes within your sample are the number of successes divided by your sample size. And so n times p hat, if you were to work out this algebraically, n times p hat gives you x, which is your number of successes. So the conditions are saying that your number of successes have to be bigger than 10 and the number of failures have to be bigger than 10. All right, let's get into an example. A candy manufacturer sells bags of chocolate treats that are supposed to be half dark chocolate, half milk chocolate. The CEO opened a bag of the chocolate treats and told his factory supervisor that he thinks the types of chocolates are not evenly split in the bag. The supervisor randomly selects several bags, examined 250 of the chocolates, and he found that 47% of the 250 chocolates he examined were dark chocolates. Use a TI-83, use a calculator to test whether the true proportion of dark chocolates is different from the 50%. Okay? All right. So first step, as always, is to construct your hypothesis. Since we are working with a proportion, instead of using mu's, we're going to use p. So we need to test whether the proportion of dark chocolates is different than the 50%. So we are testing if p does not equal 50%. Always, always write your percents as decimals, 0.50. This is our claim, which is the alternative hypothesis. So the null hypothesis is that the proportion of dark chocolates equals 50%. Okay. So we are testing proportions, so we're going to do a one prop z-test. Okay. If you click on one prop z-test, there are some things that we need to input to the calculator. What are these things? Let's see. So we need a p naught. This is your hypothesized proportion. This comes from your hypothesis. So our p sub 0 is a 0.50. You need an x and an n. Well, your n is your sample size. Your n is 250. Right? There's a total of 250 chocolates that were selected. But 47% of those chocolates were dark chocolates. So X represents, let's grab a different color here. X represents the number of dark chocolates. Okay? And so they tell us 47% of the 250. So the number of dark chocolates for us will be 47% times 250. So we're going to take a 0.47 and we're going to multiply that by 250. So 0.47 times 250 gives us 117.5. Okay? So let's put that in. We get 117.5. But here's a very important piece of the puzzle here. You cannot have a decimal for your X or your N. We can't have half of a chocolate. That makes no sense. Or think of it in terms of people. What if we were selecting people? We can't have half a person. So what we're going to do is we're going to round that 117 up, 0.5 up to a 118. And the general convention is to always round up. Okay? So we're going to let our X be the 118. If you put a 117.5 into the calculator, you will get an error. Okay, our N is 250. And we have a two-tailed test. So let's put all this information into the calculator. So stat test, one prop z-test is number 5. Our p naught was 50%. If you remember, we're trying to compare it to 50%. Our x was 118. And our n was 250. And this was a two-tailed test. Okay. We go to calculate. And what we get from the calculator is several outputs. So I skipped over all the steps, but every single hypothesis test has the same steps. You have to calculate the test statistic, and from that, that's how you're able to get the p-value. Well, the test statistic for this situation was a negative 0.89 if we go to 2 decimal places. And our p-value, the p-value is the one without the hat on it. The p is a 0.376 if we were to round to 3 decimal places. And your p-hat is found by taking x divided by n. So 118 divided by the 250 gave us that 0.472, which is close to that 47%. We're off a little bit because remember we had to round. So anyways, our p-value is a 0.376. Okay. And hopefully if you watched the previous videos, you know from here, same old song and dance. What do? To make a decision, we take our p-value, compare it to alpha, which was 5%. Told us that right up here. 376 is greater than alpha of 0.05. So then we're in a situation where the p-value is greater than alpha, which means we must fail to reject the null hypothesis, which means our interpretation is that there is not enough evidence to support the claim. So what that means is that the CEO is Incorrect. We don't have enough evidence to prove that the proportion of dark chocolates is different than 50%. Okay, so you notice in this one how they gave us a percentage here. So you have to multiply to get your x value. Sometimes they'll give you the x directly. For instance, if they had said and out of the 250 chocolates, 113 of them were dark chocolates. Well, there's nothing to multiply. Your x in that scenario will be a 113. So make sure you're comfortable both ways with that. Okay, one more example here. A medical research says that less than 25% of U.S. adults are smokers of cigarettes. Okay, in a random sample of 200 U.S. adults, 18.5% say that they are smokers. Use alpha of a 0.05. Test if the population proportion of U.S. adults that smoke is less than 25%. Okay, I'm going to go to this one quickly. We need to first write the hypotheses. Well, we are testing the claim that the population proportion is less than 25%. 0.25. Always write percents as decimals. Otherwise, we're going to let p equal 0.25 to give us the null hypothesis. All right. We know we're going to do a one prop z-test because we're testing a proportion, and there's just one sample, one survey here. We know that p naught comes from the hypothesis, so it's going to be a 0.25. We don't know the x directly. We'll come to that in a second, but we know n, our sample size, was 200. Well, what's x? X is going to be 18.5% of the 200, meaning we take a 0.185, I'm rewriting that percent as a decimal, and we multiply it by 200, and that should give us 37? Let me double check that. 0.185 times 200 gives us, yes, 37. Say it with your chest. All right, so our x is 37. So this one, once again, we had to multiply to get the x. Now it's just a matter of putting everything into the one prop z-test and getting out your p-value. Going to number 5, which is the one prop z-test. Our p naught was a 0.25. X is 37. The n was 200, I believe. And this was a left tail test. Why? Because the HA was a less than, left tail test. So we got to make sure we select the middle option here. Okay. We calculate, and let's look at that p-value to 3 decimal places. Should be a 0.017. So our p-value is a 0.017. All right, alpha is 0.05, so we take the 0.017, compare that to our alpha of 0.05. I'm going to add an extra 0. 17 is less than 50. The p-value is therefore less than alpha, which means we should reject the null hypothesis, which means there is enough evidence to support the claim, because the claim is an horizontal, is a alternative hypothesis. All right, I hope these hypothesis tests are starting to make a little more sense to you. See you in the next one.